Let's move on to our next topic about typecasting. And I would like to talk about the motivating example on my iPad. And then we'll discuss why we really need typecasting. Let's consider this small fragment of code where we got two variables over here. We got Jim of a particular static type, and we got RS of another static type. Okay, let's put it in the diagram here. So just get ready. So we got Jim, and just remember its static type is simply students. And also we got RS, and then its static type is resident students. Okay, and then we do the first line here. We want to create this particular Jim variable over here, and then we want to assign dynamic type to it, resident students. According to what we learned previously, this would be allowed because the resident students over here can fulfill all the expectation that we can impose on Jim, which is a students. Okay, that's something, if you're not sure about this, you can review from the previous video. Okay, so once we do this, we're going to create this object over here. So the name will be J Davis. And by default, the courses will just be empty list. And also for the premium rates, it will just be 0.0. So that's what we got, right? And then Jim is actually going to point to this particular object over here, right? So you can see now what we have is Jim's static type is students, but its dynamic type is simply a descending class, which is completely valid. And now let's say we want to perform this line over here in orange. If we say RS is assigned to Jim, would this be allowed? Before you say anything, let's say what the intention is. The reason we want to do this is because we realize Jim is actually dynamically pointing to this particular objects at the runtime of type resident students. So we really want to say, why don't we simply let RS also pointing to this particular objects over here, and then so that we can set the premium rates of that object to be 1.5. In that case, you can think about what that should do is to assign that into 1.5. That's our intention. However, is what we intend to do right now going to be valid? Is it going to be allowed by the compiler? The answer is no. This will not even compile. That's what we thought in our mind. We thought it makes sense, but it doesn't make sense to the compiler. So this is not going to happen, okay? And then this also is not going to be allowed. So this is not going to compile. Not valid, and you will fail the compiler check. So this line over here, as we learned previously about a rule for substitution, we know that for Jim, its static type is students, and RS is of static type RS. And if you want this to work, we have to make sure the expectation of the left-hand side, which is the RS, it should be at least be covered over here, right, by the expectation of the right-hand side, the static type of Jim, which is students. And is this the case? Definitely not. So this is not the case, because for one counter example, right? So you can think about, let's say, premium rates. Premium rates is a member of this particular expectation set, but it's not a member of this particular expectation set. So this will not even compile. Okay, so what's the point of talking about this example here? I want to show you a very simple scenario where we, as the programmer, we are so sure that Jim is really pointing to this particular object at the runtime, but why the compiler is being so inflexible about allowing us to really assign RS into this particular resident student object, which completely makes sense, right? And the compiler is so obsessed with the idea that you simply cannot assign something that is statically a student into something that is statically a resident student without even considering what is really being dynamically being pointed into. Okay, so that's something I would like to talk about, and this really raised the motivation for typecasting. But before I talk about how you can do typecasting to resolve this problem over here, let's talk about why the compiler would behave like this, being so inflexible. Okay, so now I would like to give you a A+ challenge. Let me present to you this problem over here. If you're able to write me a program, it doesn't need to be in IFO. If you can write me any program in C, in Python, in Java, or in any other language, if you can create to me this program over here as I described below, you can receive A+ for this course right away. Okay, so let me talk to you about the program. The program you can write for this challenge. You're going to write some program over here. Okay, doesn't matter how you design that. The program is going to take two inputs. It's going to take, let's say, one info class over here, myClass.e. Okay, and then the class can be arbitrarily written. It might contain if statements, it might contain loops, it might contain maybe attributes, routines, and etc. It can just arbitrary. And then it's going to take some string s. You can think about that one is like a variable name. Okay, and then your program is going to output something very simple. The output is going to be what is the last dynamic type of variable s. You can assume that always when we actually put s over here from the input, it's always going to be a reference variable. Okay, so you can always have the last dynamic type, assuming that it's being initialized. Okay, so let me just give you one example here. The input for myClass.e can be something like this. Okay, so my class, you can think about it has a make routine, and then you declare maybe local variable s. So the s really matches the s over here. And then let's say a very simple line. If you simply say creates s.make, and the dynamic type will just be resident students. So that's the dynamic type. So that means the last dynamic type of s will just be resident students. That will be your output. However, your program should really handle any arbitrary inputs of myClass.e and any variable name I might give to you. Okay, can you write such program? If you can receive an A+ right away for this course. All right, so I'm not sure if you really see beyond my offer over here. So what I'm offering to you is actually impossible. If you could do this, you actually deserve more than A+ in this course. You might even deserve a Nobel Prize, because this has been proved theoretically impossible. For those of you who actually took the EECS3311, the introduction to the theory of computation, if you're on the engineering side, don't worry. Let me just briefly talk about the issue with you. So whenever we talk about computation, there is limits as to what we can do, what we can program the computer to do. And there is a class of problem there called undecidable. Undecidable, briefly speaking, it simply means that there is no efficient algorithm, or it's simply just not possible for you to actually write the algorithm for the problem itself. So now, in order to write this particular program over here, it's simply an undecidable problem. You just cannot decide what the output should be with arbitrary input. I'll just give you one example here. So let's say if I arbitrarily, because your program doesn't really know in advance what the input might be. So for example, if I simply put maybe from a from loop until, and then some Boolean expression over here, and then whatever loop over here, right? If I put it there, and now let's say the Boolean expression here can be arbitrarily complicated. I can put some very complicated expression there that will simply just evaluate to false. So what does that mean? That means this loop over here is never going to terminate. So you can never reach this line over here. In that case, how can your program tell what the dynamic type is? Or how can your program tell in the first place why this program over here is actually is not going to terminate? So the best your program can do is to somehow simulate what the input class will do, to simulate. If you want to do some formal proof, as in 2001, that's exactly how you prove it. The best way your program can do is really to simulate exactly how the input myClass.e is going to run. However, if myClass.e, the input, is going to loop forever, in that case, your program itself also is not going to terminate. So you never get the answer. Okay, so that's really something I would like to talk to you about this particular problem here. And this is really the inherent problem that any programming IDE, like iPhone Studio, Visual Studio, or Eclipse, they are facing. So the compiler in the OOP, they simply just cannot keep track of the dynamic type for any variable, even for a simple case like this. Even though we know that Jim at this point, dynamically, it's really pointing to this particular resident student's objects, even though it's the case. But compiler simply doesn't keep track on that, because even though it can resolve in this simple case over here, but it just cannot resolve in general. So it simply just doesn't support, keeping track of the dynamic type. Okay, hopefully you see my point. So that's why for us as a programmer, number one, we realize the compiler should follow some very strict rule of substitution as we talk about, number one. Number two, for us, if we are really sure at the point of doing this particular assignment, if you're so sure that Jim is really pointing to something dynamically that should be valid for our purpose, in that case, we have to signal to the compiler by using a typecasting. So that's exactly the purpose for typecasting. So why don't we talk about how we can do typecasting quickly? Okay, so the syntax goes like this. So we learned about this check syntax already. So we got check over here, then, and also end. In your lab number 0, you simply got attached and then Jim as rs Jim. We talked about it already, right? So for that part, I'm going to omit. So now the only new part is you have to put curly brackets over here and then put a new type, put some type in there. Okay. So what we're doing over here is we are trying to see if Jim dynamically can fulfill the expectation for resident students. Basically, that's what we are trying to do. Okay. So now, can the dynamic type of Jim fulfill the expectation of the resident students, which is the type that's put in here. Okay, if it can, meaning that the dynamic type over here is a descendant class of resident students. If it can do it, well, of course, including the resident student class itself. If it can, then we're going to do the following. Be careful about what I'm going to say here, right? If it can, so that means the entire expression over here is going to be true. Number one, okay? If it can, number one, the expression is going to evaluate to true. Meaning that, first of all, we're going to pass this check assertion over here. Number two, we're going to create an alias. Alias to what Jim is pointing to with a different static type. So remember we said before, Jim, once declared of static type, students can never be changed. So we cannot modify the static type for Jim. But what we can do instead is to create a local variable there that's an alias to Jim. So what we're doing is rs Jim is pointing to just the same objects. However, from the compiler's point of view, for Jim, its static type remains to be students, as we said before. However, for the static type for this rs Jim, the local variable, given that the assertion is actually true, so that means its static type has been initialized to be resident students. Okay, so we can put rs. That's from the compiler's point of view, with the static type rs. Okay, so these are the two consequences of this typecasting, which is very similar to what you did in Java. I'll show you the similarity in just a moment. Okay, so after this, in the context of this check assertion here, as given that the assertion actually passes as true, so that means when we can get into line number 2 to do rs is assigned to Jim. So now, would this line be valid? The answer is it's going to be valid, because if you try to do assignments again, rs Jim, you can see the static type is rs Jim. Okay, and then if you try to see rs over here, as we declared before, you can see rs was declared to be resident students. Okay, let me put it there. So that means rs, the static type is resident students. Okay, the static type is resident students. So now, can the resident students class fulfill the expectation of rs? Yes, of course, because it is. So rs is the descending class of itself. So of course it will be okay. So in that case, we will be able to do this particular assignments, and the consequence of that is rs now is going to point to wherever rsgym is pointing to. Let me just be more explicit over here. So rs is going to point to this particular object, which is exactly what rsgym is pointing to. That's what we're doing. Okay, and then of course that's also what gym is pointing to. So just you have to know what's really happening behind the scene. We're really just creating a new alias over here with a more specialized static type. Okay, and then after this, if you say, well, I want to do rs.set pr 1.5, this is what we originally intended to do. So now if you say rs and then set premium rate to be 1.5, yeah, you will simply set it from 0.0 to 1.5. That's what you will do. Okay, so that's about the syntax for cast. And one common question is, can we actually use maybe if then else rather than the check assertion? The answer is it depends on what you really need. So let me be straightforward over here. So if you say if rather than check, and then over here I say attached, and then resident students gym as I would just say R over here, just for short. I'm just running out of space. Okay, so now if you put an if then else as R, and then over here you can see pretty much everything is the same, except that I'm just using the if keyword over here, and then under which I can simply say rs is assigned to R over here. Okay, and then we say rs dot set premium rates 1.5. Okay, so what will be the difference over here? The difference goes like this. If you put this particular expression over here, which is the same in both cases, right? So these two are exactly identical. If you use the check, so that means you are so sure about the dynamic type for gym that should be fulfilling the resident student's expectation. If it does not, at the runtime, you're going to run into assertion violation. Okay, so now you actually want to say if false from this particular expression over here. If that's false, in that case you're going to get assertion violation. On the other hand, if you're using, let's say, this particular alternative, so if it is false, so that means you can have the else part and maybe do something else. In that case, you would not run into the assertion violation at the runtime. So now you got basically two alternatives, either alternative number 1 or alternative number 2. There is no right or wrong, so it's just about what you really need. If you are so sure about the dynamic type at this point and you believe that should be the case, then use the check. If you want to make it more conditional to say if it can be cast into this local variable R, and then I'll do something about it. If it cannot be cast, I'll do something else. Okay, so that's the difference. Let's now go back to the slides, and we have basically talked about the very first 2 slides about the typecasting. Okay, so we talk about these examples over here already, and then that's the syntax. Okay, just to make sure you understand the 2 consequences I mentioned before for if you do a typecasting. And also, these are just more explanation about what a cast is really about. Okay, I'll let you read it. Everything has been demonstrated already. And then, so this is more or less the equivalent of using the instance of. While you can think about the attached syntax, it's a little bit similar to the instance of, similar. So if you have some knowledge about exactly what the rules should be for the instance of from Java, in that case, it will also apply in this case, right? And then in the check case, if it cannot be cast, then you will simply say check assertion error. It's like an exception at the runtime. So that's why I show them as kind of the equivalent fragment of code, like approximation. Okay, so that's about the syntax for the cast. So now I would like to talk about some notes, some special properties you should know about the cast. There are 3 written notes on your slides. So to complement these textual descriptions, I would like to do some visual demonstration on my iPad. And then we'll see. And we'll try to make some conclusion actually from there. Okay, so let's consider this example over here. So first of all, we start with by declaring my phone over here of static type iOS. So let's mark it on the inheritance hierarchy. So it's iOS over here. And now let's say first of all we do the following. We try to create a try to attach my phone into some dynamic type for the first time. So can we do iPhone 11 Pro? If you try to mark the place of this particular proposed dynamic type, iPhone 11 Pro. Would this be okay? Well, apparently that would be okay. The way to check is whether this particular dynamic type over here can fulfill the expectation of iOS. Apparently yes, because for sure this descendant class over here can always fulfill what's really imposed as expectation on the parent class or ancestor class. Okay, so that's the first point I'd like to make. And then once you have done this, you can actually see the textual description over here. So now, what can we call on my phone? My phone right now is statically declared to be iOS. So anything that's actually available on iOS will be okay. So that means you can call surf web. That's you can definitely call dial and surf web, and also FaceTime, right? So these are the expectation. So now FaceTime for sure, dial and also surf web. However, you cannot call any quick take. Especially you can see that it's very important to see, even though the dynamic type is actually iPhone 11 Pro, which got quick take available. However, the static type for my phone currently is simply iOS. So can you call the quick take? No, you cannot. Okay, so that's why. And also similarly for other feature, you just cannot call. It's outside the expectation for iOS statically. Okay, so these you cannot. Okay, that's the first point I'd like to make. Let's go to the second point. We're having the same example over here. So let me just set the context again. So we got iOS, static type, never changes. And also currently, after this initialization, this is the dynamic type. Okay, so now let's consider a first cast, which I'm going to use maybe orange over here. So we are saying that we're gonna do just say check. You know, you can do if then else if you wish. We want to cast my phone into smartphone. So you can think about we are really doing the so-called upward casting. So we are trying to say whenever you're doing upward casting, that means you're trying to narrow down the expectation. So you can think about we are trying to go from iOS, the static type, into this particular cast type. So this is like upward casting. Upward casting. So in which case we are narrowing down the expectation. So now and then, would this be okay? So now what you gotta ask is, can we actually do this particular cast? Can we do that? So the way to determine will be, can the dynamic type for my phone fulfill this particular new expectation? And then if it can, then we'll create this alias called SP. Okay, can we? Well, definitely we can. iPhone 11 Pro, can it fulfill the expectation that's on the smartphone? For sure, because iPhone 11 Pro is a descendant class of my phone. Yes, so that'll be positive. So we can do it. So once we do it, you can see SP right now is going to be of static type smartphone. That's exactly the definition for casting that we talk about. And now for SP, what can we call on that? Is SP going to have a narrower or wider expectation compared with my phone? Because it's an upward casting, so it turns out SP has a narrower expectation than my phone. And which, to be more precise, which expectation do we take out? Well, FaceTime, right? Because now my phone simply just does not have the FaceTime available. So now if you look at that, you will see in the textual description, you can also see the description on your slides. So now for dial and surf web, no problem, because they are definitely defined in the smartphone level. However, for example, you can see for the FaceTime specifically, it's not available anymore. Okay, on the SP for sure, because now the static type is smartphone. Okay, and also for all others, they are simply also out of the expectation for smartphone. Okay, so that's about the upward casting. And then you might be wondering, why would upward casting be useful? I would say it's more about maybe about access control. So let's say if you want to pass the reference or some alias to other external clients, and now you rather than just passing some reference of static type iOS, in which case people can clients can actually call FaceTime, maybe for security reason or for access control reason. You don't want them to really have this particular ability to call FaceTime. In which case you can still let them point to the same object over here, but you're going to let them have a narrower or like a more restrictive static type by using casting, in which case they will not be able to call FaceTime because compiler will disallow that. Okay, that's kind of like a one common reason for why you want to do upward casting. Okay, let's do the opposite way. Okay, let's do the third point over here. So the same setup. Okay, we still got iOS over here, and we also got iPhone 11 Pro over here. Okay, that's the dynamic type. So now what we want to do is we do the opposite direction. Let's say we want to cast into iPhone 11 Pro. Would that be okay? Well, turns out to be okay. So iPhone 11 Pro, let me highlight in orange. Can we, so orange is turns out to be here, right? So can we do this? Well, the question you want to ask yourself is, can the dynamic type of my phone, okay, can the dynamic type of iPhone fulfill the expectation for this cast type? Can it? Well, apparently iPhone 11 Pro, the dynamic type, the pink is definitely the pink is definitely the descendant class of the orange, the type we want to cast into. So in this case, it's yes. Okay, it will be okay. So after this, iPhone IP11 Pro, the new the cast variable is going to have the static type exactly iPhone 11 Pro, right? iPhone 11 Pro. So now what will be the expectation? So whenever you're doing downward casting, right? So you can think about you're going from iOS into iPhone 11 Pro for the casting. So you're going basically downwards. So this is called downward casting. And whenever you're doing downward casting, that means you're widening the expectation. So you can think about this here. So has a wider expectation than the original variable, which is my phone. Okay, given that this cast is going to succeed, so what can we call? So you can think about for now, for my phone 11 Pro, definitely you can call a quick take over here, right? It's a little bit blocked, but you can see the quick take. And also you can also do all the inherited features from the ancestor. So you definitely can do dial, surf web from smartphone. You can do FaceTime, that's from the iOS. Also you can do quick take. So all these will be okay. But on the other hand, Skype, side sync, and zoomage, they're outside the expectation for this new static type, which is iPhone 11 Pro. Okay, so that's the very first point I want you to understand, which is about either you do an upward casting or downward casting. So either way is okay, but you have to know what the consequence is. As a recap, given the static type of your variable, you can either do upward casting along the ancestor path of the static type, in which case you're trying to narrow down the expectation, or you can go the other way. Given the static type, you can cast into the descendants along the descendants path, and then in which case you're going to widen the expectation. However, as far as the compilation is concerned, as long as you are casting into one of the descendants, it will be okay to compile. However, you have to be careful. Given the static type over here and given the dynamic type over here, would it be okay if I try to maybe cast into this particular descendants, even though it will compile, but is it going to run into violation? So that's the question you want to keep in mind, okay? So be careful whenever you're doing downward casting, because even though you compile into some descendant class that will make your code compile, but it may cause you runtime violation. So that's the next point I would like to talk about. Okay, so let's now move to a more general picture over here. Let's say the following. Let's say we are trying to do a cast, in which case we are trying to cast the Y into C. So now we want to talk about what's going to happen at the runtime. So basically always compiles. You can either do upward casting or downward casting, it always compiles. But now, what if the class type C over here is not an ancestor of the dynamic type of Y? So what do I mean by that? Let's set the context over here. Let's say for Y, its dynamic type is simply over here, somewhere in the inheritance hierarchy. And however, we are trying to cast Y into C over here. As we kept saying, how do you determine if this cast will succeed? This is what you have to think about. Okay, so now can the dynamic type of Y, in which case is over here, fulfill the expectation on this particular cast type, which is C? Can it do it? The answer is no, because this cast type over here, C, which is a descendant of Y's dynamic type, in which case dynamically it's simply not possible for Y to actually fulfill this particular descendant class. It's just not possible, right? So what you're going to get would be, you're going to get a runtime assertion violation, because the cast will simply not going to succeed, because you can see that's exactly explanation. Y's dynamic type cannot fulfill the expectation on, of C. Okay, so that's a general principle you want to bear in mind. Let's see examples quickly. Okay, so let's now try different the various combination over here. Okay, first of all, let's say we got Android over here. So Android would be the static type over here, and let's say dynamic type is simply Huawei. Okay, so that's the dynamic type over here. So now let's try the various cast. So number one, can we cast into smartphone? Can we cast into smartphone? Well, apparently we can. In this case, we're doing upward casting. Agree? Okay, so now in this case, we're doing just upward casting. Okay, so this will be okay. It's a check. Okay, so this one's fine. Okay, it's just like a review from the previous example. And then you can also see over here about the static type and dynamic type, how it's going to change. And notice that for mine, we never changes its static type. Always remains to be Android. Always. All right. So that's the first example. That's upward casting. So that's completely valid. It will compile, number one, and also no runtime assertion violation. So no violation. Okay, at the runtime. Okay, let's see example number two. In this case, we still got a similar setup. So we got Android being the static type, and also we got Huawei being the dynamic type over here. All right. So now, can we cast into Huawei? Would that be okay? So we are casting into Huawei over here. So you can think about this is like a downward casting over here, right? And then we want to see right now, whenever you're doing downward casting, think about whether the cast type, which is orange, can its expectation be fulfilled by the dynamic type, which is also Huawei? In which case, yes, because Huawei is its own descending classes. So this would be okay. Okay, so this would be downward casting first of all. However, there will be no violation, because the pink is can fulfill, the pink over here can fulfill the expectation of the orange, because they are just the same class. Okay, so that's the second case I would like to talk about. Okay, what about the third case over here? Okay, again, still the same setup. We got Android static type, and also we got Huawei, so that will be the dynamic type. And now let's say we are trying to do cast into Samsung. So that's what we are trying to cast into. So number one, will this cast compile? The answer is yes, it will compile, because you're casting from Android into Samsung. So this is a downward casting. So potentially you're trying to narrow, you're trying to widen the expectation. So it's a downward casting. What about violation at the runtime? And it turns out it's going to be violation at the runtime, because think about what's happening here. If you're trying to cast mine into Samsung, you want to think about whether the dynamic type, which is Huawei, can Huawei actually fulfill the expectation of this particular downward cast type? The answer is no. So what will be the counter example? For example, you can see the side sync feature is simply not available in Huawei. So that's not going to work. Okay, so I'm gonna write down over here. It's really important. So there will be violation because dynamic type of mine, which is Huawei, cannot fulfill the cast type, which is Samsung. The cast type Samsung expectation. For example, the side sync. Okay, this is really important example here. So you can see we are having the first case where we are doing downward casting, it will compile. However, the dynamic type simply just cannot fulfill the cast type. So that means we're going to get runtime violation. Okay, so that's a third example. Let's look at the last one. So now let's see over here, we got, again, Android, the static type, and also we got Huawei, the dynamic type. So now we are trying to cast into Huawei P30 Pro. Would that be okay? Again, we're going to look at from two angles. Does it compile? The answer is yes, it is going to compile. Let me just draw the Huawei P30 Pro, which is over here. So now in this case, first of all, we are trying to do downward casting from Android down to Huawei P30 Pro. So this is a downward casting. So it will compile. So what about runtime violation? Are we going to get a violation at runtime? It turns out we will. Okay, again, you want to see whether the dynamic type, which is Huawei, can it fulfill the Huawei P30 Pro expectation? Apparently it cannot. Counterexample, zoomage over here, right? Okay, so now very similar argument over here. If you don't mind, I'm just going to copy the text. Never mind. Okay, so let me just write it down quickly. So now, because the dynamic type over here, Huawei, cannot fulfill the cast type, in this case, Huawei P30 Pro. Huawei P30 Pro's expectation. And example, zoomage. And in the slides, you will see the precise rule. Whenever you want to do any casting, either upward or downward, especially for downward casting, how can it be runtime assertion free, assertion violation free? It should be the case that the dynamic type over here can fulfill the expectation on the cast type, meaning that the cast type over here must be either it must be an ancestor of the dynamic type. It will be along the ancestor path of the dynamic type. So that's some rule you will see exactly on the slides. Okay, so really review these examples over here, and then all the 3 notes that's in the slides. Please also read the written form and then combine with this visual demonstration. Okay, before you move on to the next topic.